So good beta function, then various properties of beta function, and the duplication formula. Right now, using all these things, let's see some example on the beta function. So the very first example which we are going to solve now is to show or evaluate the value of integral 0 to infinity of e raised to power minus x square dx. Right. So tell me, is it the problem of beta function? Yes, is it a problem of beta function? So answer is no. It's not a function of problem of beta function, right? So here, as we find the exponential term, so this is the example of gamma function, okay? And limits are 0 to infinity. So as we have seen in gamma function, what we have to do? We have to put this exponential term e raised to power what we want minus of this term should be completely algebraic and its power must be 1 because variable of integration is x. So here I want completely x, right? So as it is not as per the requirement, so let's take x square is equal to say t, right? Put x square is equal to t. That is 2x dx is equal to what we have dt. So here we need the value to substitute the value of dx. So let's find out what is dx. So dx is dt by 2x. Sometimes what happens, students commit the mistake, they simply write dx as dt by 2x. So remember that what we are going to do here, we are changing the variable x completely to t. So there should not be any variable term of x. Convert this in terms of t. So if x square is t, so what will be x? That will be root t. So that is what we have to use here. So that is dt upon 2 root t. Okay. Now let's find out the change in limits. Now when x is 0, right? X is having a limit 0 to infinity and we are converting x to t. So we need limits for t. So when x is 0, t is 0. Where we are going to substitute this? Here in this expression, right? X square equal to t. Put x 0, you will get t 0. And when x is tending to infinity, then t will also tends to infinity. So therefore, this integral 0 to infinity of e raised to power minus x square dx will now take the form limits remains unchanged. It's e raised to power minus t. What is dx? Dx is dt by 2 root t, isn't it? So this is what we have. Now we will put this as per the requirement. So we will write it as integral 0 to infinity e power minus t. We will take half outside. Then 1 by root t is there, which can be written as t raised to power minus half dt. Now this need to be compared with the standard form of gamma function, right? Because we find both exponential term as well as the algebraic term. So what we have? So we have integral 0 to infinity of e power minus t, and then what we have t to the power minus half. Okay, so that minus half as per the requirement must be compared with the n minus 1 because what is the structure of gamma function? Gamma of n is nothing but integral 0 to infinity of e power minus t to the power n minus 1. So we need to identify what is n over here. Okay, so e raised to power minus t is as per requirement, limits are also as per requirement, but this t should have the power in the form n minus 1, so that we will get the value of n and we can write it as gamma of n. So here t has a power minus 1 by 2, so that need to be compared with n minus 1 so as to get the value of n. So what will be n? N will be minus half plus 1, that is half. So I will write this as half minus 1. I hope this step is clear to you all. Okay, now according to definition, here this is my n. So I will write this as gamma of 1 by 2. Okay, and we know that gamma of half is nothing but root pi. So ultimately, what we get? So we get the value of integral from 0 to infinity of e power minus x square dx as root pi by 2. So this is one of the important value. Many times in many problems we need such values. So we use this as a standard formula, and you now know how to get this value, right, by using the gamma function. So this is used as a standard formula as and when wherever it is required. Okay, now let's have the next example. So the next example is to show that the gamma of n into gamma of 1 minus n is equal to pi upon sine of n pi. Pi upon sine of n pi, where the value of n must lie between 0 to 1, right? Where the value of n must lie between 0 to 1, and here one standard integral is given. What is given? That integral from 0 to infinity of x to the power n minus 1 upon 1 plus x is nothing but equal to pi upon sine of n pi. So this we have to use in order to prove the results. Okay, so this is given. Now, so how to obtain the result? So look at the formula. What is the requirement? Here if you observe, here we have a product of two gamma function. And if you remember, in a beta function, we have a product of two gamma function only when we use the relation between gamma and function. So that is one thing which we are going to use in order to prove this result. And again, here this is the value to be obtained, and such type of relationship is given. So recall in gamma function where we have such type of integral. So if you recall, so this is nothing but in the property number 3 of the beta function, we have seen such type of expression. So here in order to prove this example, we are going to use the relationship between beta and gamma function as well as property 3 of the beta function, right? So we have, according to property 3, the beta of mn is nothing but equal to integral 0 to infinity of x to the power n minus 1 upon 1 plus x to the power m plus n. This is what is known to us, right, related to the beta function. So let's call it as equation number 1. Also, as we need the product of two gamma functions, so I am going to use the relation between beta and gamma. So beta of mn is gamma of m into gamma of n upon gamma of m plus n. Let's call it as equation number 2. Now look at these two expression. The left hand side of them is equal. So what we will do, we will equate the right hand side. Okay, so equating. So therefore equation 1 and 2 implies, on equating, what we have gamma of m into gamma of n upon gamma of m plus n is equal to integral 0 to infinity x to the power n minus 1 upon 1 plus x raised to power m plus n. Now this is what we have obtained. Now just go for the requirement. What we want gamma of n into gamma of 1 minus n. Okay, in the desired result we want gamma of n into gamma of 1 minus n. So how to get this? So for this we will have to take the value as m as what? 1 minus n. So we will just take m as 1 minus n, right, in above relation. So what we get? So we get gamma of 1 minus n into gamma of n. Now, obviously, when I am putting m is equal to 1 minus n, so what will be m plus n? M plus n will become 1. So what we have? Gamma of 1 is equal to integral 0 to infinity x to the power n minus 1 upon 1 plus x to the power, what we have? 1. Okay, integration with respect to x, and gamma of 1 is 1, so we will just rearrange gamma of n into gamma of 1 minus n, and look at this. This is nothing but given. given in the problem that its value is pi upon sine of n pi. So this we will substitute here. So what we have according to the given result, this is nothing but equal to pi upon sine of n pi, and this is how we will get the desired result, right? So now the question is, after proving this result, right, we will have the two different identities, or we can say the relation to be used when we have a product of two gamma function, right? So one is a relationship between beta and gamma function, and another is this result. So how do we decide which is to be used, right? So remember, this is to be used when we have the sum of these two functions within the gamma as 1. If you add them, what you will get? You will get it as 1. So in that case, we will use this result. Otherwise, we will make use of the relation between beta and gamma function. I hope this identification is clear to you all. Okay, now let's have another important example on the beta. Evaluate following integrals. So what is the first integral to be evaluated? Is integral 0 to infinity e power minus ax into cos bx into x raised to power m minus 1 integration with respect to x. And second result, or the second integral for which the value to be obtained is e raised to power minus ax sin bx, then x raised to power m minus 1 integration with respect to x. So if you look at this, if suppose this term is not there, if it is missing, then we can evaluate the value of remaining term easily just by making use of standard formula, right? Which we have studied in while studying the definite integration. So here, because of this term, we will have to go for the computation. Okay, so how to do this? So for this, we will make use of the concept of the gamma function. Okay, so what we have, so see here what we will do, as we are observing here cos function and sine function both, so we will consider the integral, which integral, that is integral 0 to infinity of e raised to power minus ax into, I will write e raised to power I bx into x raised to power m minus 1. You will come to know how this term generates sine and cosine function, right? So simultaneously we will get the answer for both the both the integrals. Okay, so this is equal to, which we can write as integral 0 to infinity. Now apply law of indices. As I told you, if you remember, whenever the limit of integration is infinity, so we have to take e raised to power minus of variable term and remaining terms as it is, right? So I have taken e raised to power minus of x outside, and for the remaining term, law of indices will be applicable. So what we have, 1 a minus ib, right? Here law of indices are applicable, but you need to be very careful while applying the law of indices. So we will take e raised to power minus x and the remaining term. Okay, x raised to power, here we have m minus 1 integration with respect to x. Okay, now see this, we have the standard formula for such type of integral. Okay, so what is that standard formula? So that formula is nothing but, I will write here, the formula which is known to us is integral 0 to infinity of e power minus kx into x raised to power n minus 1 dx is nothing but what? It's nothing but gamma of n upon k raised to n. So just compare the given integral whether it is in this form or not. Okay, so here you find e raised to power minus, this is kx, x to the power in place of m, what I am having here, n. Okay, so by making use of that result, standard result which we have proved earlier, I can write the value of this as equal to what? Gamma of m, n is nothing but m here, so gamma of m upon what we have, k. K is a minus ib. Okay, k is a minus ib here, so a minus ib raised to power n, n is nothing but here in this problem m. Okay, so by the standard result, so since this, and here the value of k is a minus ib, and m is nothing but uh, n is nothing but equal to m. Okay, now, so we have obtained such expression, but the thing is not solved. Why? Because here we want sine or cosine function. Here either we want sine or cosine function. So what we will do? So what we are going to do now is we are writing this exponential for we will use the formula, the Euler's formula. What is that Euler's formula? So it says that e raised to power I theta is always cos theta plus I sin theta, right? E raised to power I theta is cos theta plus I sin theta. Again, if we have again we have here the term a minus ib, right, raised to power m in our expression. Okay, so what we are going to do now, we will put a as k cos theta and b as k sin theta, right, for the sake of simplification. That is uh, what that is for separating this into a real and imaginary part. So these things we are going to implement now. So what we have? We have integral 0 to infinity of e power minus ax, right? Here, then this is to be written as what? Cos theta plus I sin theta. So what we have? In place of theta, we have bx. So cos bx plus I sin bx. Then x to the power m minus 1 is there, dx, integration with respect to x, is equal to what we have, gamma of m, and then I have written a minus ib. A minus ib, a is k cos theta, b is k sin theta, right? So according to that expression substitution, what we have, so it is k cos theta a minus ib, I times k sin theta raised to power, what we have m. Okay, like this it is done. Okay, so since this, now just multiply these terms, e raised to power minus ax cos bx into x raised to power m minus 1, then we have another term as I times e raised to power minus ax sin bx, like this. Okay, now so what we have this as integral 0 to infinity, then e raised to power minus ax cos bx x raised to power m minus 1, integration with respect to x, plus I is there which I will write outside the integral, then integration from 0 to infinity e power minus ax sin bx x raised to power m minus 1, integration with respect to x, and then look at the right hand side. Here I can write sin theta as sine of minus theta, right? Minus sin theta as uh, plus sine of minus theta. Okay, so using that concept, what we have here, so by de Moivre's theorem, this term will be taken in the numerator, right? So what we have, so it's just a minute. So it is k outside, right? Here I can take k outside, that is k raised to power m. So we have 1 upon or gamma of m I will write upon k raised to m, and remaining term I will write in the numerator. So it is cos theta minus I sin theta raised to power, when I will take this in the numerator we have minus m. Now here I am going to use the de Moivre's theorem. Maybe you were aware of that de Moivre's theorem. So what it says that this gets multiplied with the angle, right? So what we have, gamma of m upon k raised to m. So we have cos of minus m theta, and we know that cos of minus m theta is same as cos m theta, right? And then here sine of minus m theta, and sine of minus m theta is minus of sine m theta. Already there is minus sign, so that becomes plus. So plus I sine of m theta. In this way, this is obtained. So this is because of de Moivre's theorem. Okay, now here on the right hand side also I can separate the terms, right? So what we have, integral 0 to infinity e power minus ax cos bx into x raised to power m minus 1 integration with respect to x plus I times integral 0 to infinity e power minus ax into sin bx x raised to power m minus 1 integration with respect to x is equal to gamma of m upon k raised to m, then cos m theta will be the first term, then plus I times gamma of m upon k raised to m, then sine of m theta. So this is called as a real part, whereas this will be imaginary part because this is getting multiplied with iota. So now left hand side is in the real and imaginary part as well as right hand side also. So what we do, we will just equate the real part. Real part means the term which is not containing I. So this is real part in the left hand side. This is real part of right hand side. Whereas term with multiplied with iota is the imaginary part, right? So this is the imaginary part. Here this is also imaginary part. So just equating real and imaginary parts will serve the purpose. So on equating the real and imaginary parts, we get, so real part on the left hand side is integral 0 to infinity e power minus ax cos bx into x raised to power m minus 1 is equal to, you can see here, then is equal to what we have, gamma of m upon k raised to m cos of m theta. Whereas the on equating imaginary part, we get integral 0 to infinity e raised to power minus ax sin bx into x raised to power m minus 1 integration with respect to x is equal to gamma of m upon k raised to m sin of m theta. In this way, the value of both the integrals are obtained simultaneously. So I hope this substitution is clear to all. Obviously here, what is the value of k? So k is nothing but, I have used the substitution. If you look at this term, that what substitution, a is k cos theta and b is k sin theta. So what will be the value of k? If you will find out the value of k, so what it will be, just squaring and adding both the sides. So a square plus b square will be k square times cos square theta plus sin square theta. That is 1. So k square is a square plus b square. So what is my k? K is nothing but under root of a square plus b square. Okay. So here we should mention what is k. K is under root of a square plus b square, and on the same line theta is also required. So theta is tan inverse of what we have, b by a, like this. The proof is done, right? So in this way we get the value of the integral. So I hope this is clear to you all.